23-42 Goldstone. DSS-14 catches a stray carrier. Every 19.3 seconds, the spectrum flinches, as if the moon breathes. Polar cold traps won't cool. A Doppler edge slices the disk, metal under dust. We whisper a test code. Something inside the moon blinks back. Goldstone, California. The desert floor radiated its heat long after sunset, leaving the air dry, metallic, and sharp against the skin. Inside the control building, the Deep Space Network hummed with predictable rhythms. Oscillators ticking, cooling fans droning, the faint vibration of transformers layered beneath fluorescent lights. At 2342 PDT, the 70-meter DSS-14 antenna had just completed a routine downlink session with a lunar orbiter. The shift engineer expected nothing beyond the usual checksum verifications and telemetry silence that followed termination. Yet in the diagnostic channel, a narrow carrier appeared. It did not belong to the orbiter. Its frequency lay offset, stable and precise, displaced by 127 kHz from the expected band. No modulation rode upon it. Its amplitude was low, almost fragile, but the spectral readout showed symmetrical side lobes breathing in and out every 19.3 seconds. On the monitor, they resembled lungs, vast and slow, pulsing across a flat line of background noise. The engineer adjusted the azimuth logs, checked elevation, and confirmed the source alignment. The origin pointed directly toward the lunar disk. Nothing else within the beam width matched. A dry note was entered into the console's log. Unscheduled tone. Origin, lunar disk. Repeat confirmed upon antenna stabilization. The phrasing was standard, stripped of interpretation. The night passed without escalation. No alarms, no corroborating anomalies from the orbiter, no interruptions in other telemetry. When dawn came, the data file was automatically transmitted to Pasadena. Its label bore the habitual tag Anomaling Minor. At the Jet Propulsion Laboratory, analysts cross-checked the signal against the reference generator. They aligned it against the vector analyzer's calibration sweeps. They compared it against the registry of nearby military emitters known to bleed into deep space bands. Nothing matched. Protocol dictated external verification. A copy of the recording was routed to Green Bank, West Virginia. The telescope there, heavy within its radio silence zone, was idle enough to scan. Hours later, the reply arrived. During the night window, when the lunar disk sat low over the Appalachian ridges, the same carrier had brushed across their receivers. Its amplitude was weaker, filtered through terrain and horizon, but the 19.3-second side lobe interval was identical. By morning, a series of memos began to circulate internally, each repeating the same conclusion in different phrasings. Non-operational anomaly. External source uncorrelated. No immediate action required. The wording was chosen not to clarify, but to contain. Yet within the broader research files, the signal sparked a faint comparison. Years earlier, Apollo seismic archives had been digitized and shelved. The data had been famous for one characteristic. When spent Saturn V stages were crashed deliberately into the surface, the moon rang like a struck bell. Its seismic profile revealed a body with unusual internal elasticity, sustaining vibrations with an unexpectedly high Q factor. When an intern layered the modern carrier's pulse sequence over the old Apollo traces, the spacing between peaks aligned. Not approximately, but precisely, down to hundredths of a second. The moon's ringing carried the same rhythm as the present carrier's breath. The overlay was noted, footnoted, and dismissed. Statistical fluke, mathematical coincidence, pattern seeking in noise. That was the phrase typed into the internal database. The file closed itself, archived under standard indexing. By evening, Goldstone returned to its usual cadence. Operators tracked Earth-crossing satellites, recalibrated antenna arrays, adjusted telemetry feeds for temperature drift. The logbook retained only a single line of text about the previous night, a line so neutral it seemed designed to erase itself. Anomaly non-operational. In the desert wind outside, the antenna turned silently, its steel ribs catching the starlight, following targets across the black sky. The unexplained signal faded into routine, catalogued, dismissed, and buried in the noise. But the record existed. A fragile carrier in the S-band, displaced and unmodulated, pulsing in intervals that resembled respiration, marked the data for those who might look again. It remained a minor anomaly, the kind filed away without urgency, awaiting another night when the moon's disk would offer its silence to the listening machines below. A week after the carrier was first logged, the anomalies spread beyond the narrow confines of antenna diagnostics. They began appearing in places that were never meant to overlap, in instruments designed for tides, heat, background noise, and reflections. Each fragment seemed small, dismissible in isolation, but together they formed a lattice, a faint shape that resisted coincidence. At no AA coastal posts, tidal records came in with unusual clarity. Normally, the residual adjustments tied to lunar gravitation traced a restless line, drifting with barometric shifts, winds, and seasonal corrections. But now, across multiple stations, Portland, Charleston, Mobile, Boston, the correction trace flattened. The usual wobble dissolved into a ruler-straight plateau that aligned with the same 19.3-second rhythm noted in the Goldstone carrier. It was not a visible pulse, not an obvious oscillation, but a steady, silent plateau embedded in the nighttime intervals. A memo drafted during a tide service meeting reduced it to procedural terms. Possible phase filter drift. Recommend inspection of converters. The language disguised unease, as if the data itself had conspired against familiar margins of error. In Arizona, USGS teams at Flagstaff worked with infrared composites of the lunar surface. Their project focused on mapping nocturnal heat distribution, particularly within permanently shadowed craters near the poles. For years, the temperature basins of those cold traps had been consistent. Steady lows, extreme but predictable, locked in by geometry and absence of sunlight. In late September, however, one basin on the rim of Mare Frigoris registered a plateau. The crater floor held its temperature 2 to 3 Kelvin higher than model expectations for several hours. No correlation matched albedo variance, solar angle, or regolith scatter. On the margin of the report, an analyst had written by pencil, "Radiator behavior, if not error." The phrasing, tentative and speculative, implied something deliberate, as though heat had been stored and bled in increments. Meanwhile, in Virginia, the Green Bank telescope logged a curve of its own. The senior operator posted a plot of system noise temperature onto an internal channel. For much of the night, the curve followed its expected trajectory, but in the center of the observation window came a sudden clearing. Noise dropped, not sharply, but cleanly, as if a swath of spectral clutter had been absorbed or erased. The chart showed it as a trough, elegant and unsettling, a silence imposed on the sky. A technician, asked whether nearby transmitters had been powered down, answered with a clipped line on the shift board. The surrounding county was silent, as prescribed by law. Out west, Nevada's high desert yielded another fragment. North of Tonopah, a mobile spectral station operated by a defense contractor recorded routine data for a classified contract. Its work was not designed to target the moon. It gathered background scatter and ionospheric spillover for comparative analysis. In the logs from October 12th, the analyst later found a thin discontinuity at the lunar reflection edge. A phase shimmer so faint it seemed like artifact sat at the boundary of the return. It matched neither tropospheric multipath interference nor satellite echoes. In the margin of the file appeared a terse annotation, "Uncharacteristic step." No further elaboration followed. By mid-month, desks across the agencies began to accumulate this kind of dust. Graphs, notes, small sketches, raw extracts, all fragments of behavior recorded in systems that rarely conversed. Tidal plots, thermal anomalies, spectral troughs, phase shimmers. Each was trivial when viewed alone, the sort of data folded away without remark. Yet when aligned, a contour emerged. The moon was participating in the instruments. Not loudly, not disruptively, but with a consistent presence that returned in rhythm and temperature, in noise and silence. No alarms were raised. No warnings reached the public. Analysts placed checkmarks beside the plots, added thin overlays to composite maps, archived the pages. They moved forward with protocol, but a quiet understanding circulated beneath the paper trail. Something was shaping itself in the margins, pressing lightly against the edges of measurement, leaving behind a memory in fields that should have been neutral. It was not explanation that grew, but accumulation, the sense that absence itself had begun to respond. In Pasadena, the coordination began under the dull language of administrative headings. A closed call was assembled with representatives from Goldstone, Green Bank, the USGS, the Applied Physics Laboratory, and a private contractor known for its capacity to remain invisible in records for years at a time. The agenda avoided sharp words. It was framed as an alignment of experimental protocol for lunar radar volumetric returns during intervals of heightened plasma activity within Earth's magnetotail. Behind the phrasing stood a simpler idea. They intended to illuminate the moon in a way it had not been illuminated for decades, with a broad, low-power sweep in the S-band synchronized to the nocturnal breathing window that had crept into graphs and margins. Preparations unfolded quietly. At DSS-14 in California, engineers cleared a clean channel, checked amplifiers, and confirmed that the desert weather would remain steady. In West Virginia, the operators at Green Bank calibrated receivers to listen off-frequency, tuned for anything returning from a direction or phase where no echo should exist. In Massachusetts, at Haystack, specialists activated Doppler color mapping software to capture any slight shifts in surface phase distribution. In Denver, a modest office attached a sheet labeled Accompaniment to the shared file, a document without signature that marked participation while saying nothing. The first run followed procedure with mechanical precision. Minutes of brushed signal, then a pause, then another sweep, repeated again and again, each cycle designed to accumulate triviality. No one expected deviation. Lunar regolith was noisy, rough, and stateless. Its scatter obeyed statistics, not design. Yet on the 27th pass, Green Bank's monitor registered something no chart had predicted. Within the haze of returns, a line appeared. It was sharp, not gradual, like the boundary of a polished edge. The usual chaos of rock scatter gave way to a cut, a discontinuity with the clarity of a blade. The edge moved. Slowly, almost reluctantly, it shifted across the noise field as if some plane beneath the crust were turning, exposing a smooth facet where no surface could exist. The operators marked it without annotation at first, then attached the word boundary. Hours later in the shared notes, it would be remembered differently. The edge. Haystack's instruments confirmed the strangeness. Instead of the random patchwork expected from regolith scattering, their Doppler mosaics aligned. Hundreds of discrete points across the visible disk rippled in synchrony, producing a pattern that implied coherence. For brief seconds, the signals suggested that a thin skin had replaced dust and stone with something uniform, something that behaved like a surface. At Goldstone, the console logs described the background echoes as softened, their usual granularity reduced. In the cold wording of the test sheet, it was entered as a variation in scattering coefficient, but internally, the engineers compared it to the sound of cloth stretched over a frame. The anomaly did not repeat endlessly. It arrived, held for a breath, and then collapsed back into noise. The official record of the session extended to 20 protocol pages. 5 paragraphs addressed safety, transmitter health, and local weather. The remaining 15 lined up the facts in neutral order. Anomalous responses had been observed, repeatable only under narrow windows, dependent on bandwidth, and a persistent period of 19.3 seconds. The conclusions avoided conjecture. The reports contained no adjectives, only measurements, but the shape was unmistakable. Within the private conversations of the teams, another vocabulary circulated. Slides carried only sterile headings, but in back rooms and whispered remarks, the same word recurred: hull. Not spacecraft, not vessel, just the stripped term for an enclosing surface. They said it lightly, never placing it on the protocol. The laughter was thin, the kind that rose in a room where something unacknowledged pressed on the air. The campaign ended without ceremony. Data was archived, logs distributed, cross-checks scheduled for later cycles. No title was given, no project name assigned. The files entered the system under bland headings and numeric tags. Yet those who had been present referred to it differently when they spoke quietly to one another. For them, it was the campaign that never received a name, a sequence of hours where the moon responded like an object built, not found. By the time the equipment powered down and the desert cooled in the early morning air, nothing remained visible. Instruments returned to baseline. The blade was gone. The surface reverted to rock. Only the records, stacked without comment, preserved the impression that beneath regolith and silence there had been something more. A boundary glimpsed, a reflection not of stone, but of form. And though no term entered the reports, those who filed them carried away a memory. For a few cycles, under controlled light, the moon had behaved like a structure. 3 days after the first coordinated tests, the breathing windows widened by roughly 90 seconds, and into that margin, small correspondences began to fall with a steadiness that resisted coincidence. Along Whidbey Island in Washington state, a very low-frequency shoreline station monitoring maritime bands recorded an unusual stabilization of the spectral zero point. For several minutes, centered on the expanded window, the phase plot straightened as if the medium had briefly become uniform. The analyst marked the segment, compared it with prior nights, and found no meteorological or power line justification. The plot resembled a plumb line drawn through noise. Southwest across the desert, optical trackers at White Sands noted an improvement that did not belong to the air. Seeing indices rose precisely as the lunar disk crossed a preset gate. Star images tightened by fractions of an arc-second. Frame-to-frame tip-tilt corrections diminished without corresponding changes in wind, temperature gradient, or jet stream models. The clarity arrived and receded inside the same minute when the moon's spectral breathing ran strongest. The log treated it as a transient in the atmosphere, yet the timing clung to orbital geometry rather than weather. At Los Alamos, a superconducting gravimeter reported a subtle sway of the gravity line, measured in nanogals and dismissed on most days as drift. This time, the tiny oscillation persisted across multiple windows with a period that matched the lunar pattern. Filtering removed tidal components, the signal remained. Cross-correlation lifted the repetition beyond the level of chance. In an internal annotation, the staff condensed the implication into a narrow phrase that was not a conclusion. Structural response present. The Flagstaff team at the USGS extended polar thermal maps and saw the plateaus repeat. Night after night, several cold trap craters held to the same slight elevation in temperature for the same aligned intervals, then fell back into shadow as if a row of silent radiators had cycled down. When the model attempted to assign the behavior to rock inertia, emissivity adjustments broke other fits. When thin ice lenses were added to carry the heat, the plateaus ended too late in the run. The residue of mismatch encouraged one more marginal note that did not belong on a geological chart. The word management entered a margin without boldness, a private hypothesis that would never land in an abstract. Elsewhere, the correspondence proliferated. GPS total electron content maps compiled at JPL showed a faint annular reduction in TEC centered near the sublunar point, appearing only inside the window and absent on adjacent nights. The annulus was wide and shallow, the kind of modulation that could be erased by a different choice of color table, yet it reappeared whenever the geometry matched. Magnetometers at Boulder and Fredericksburg picked up a narrowband micropulse that sat uncomfortably between categories, too fast for the usual geomagnetic pulsations, too structured for station noise. The oscillation sank as antennas turned off and rose again at the next gate, as if the ground heard a breath through lines of steel. The very long baseline interferometry session at Mauna Kea and Owens Valley noted a picosecond jitter that marched in steps when a quasar near the lunar limb was used for calibration. The delay compacted and relaxed with a cadence that fit the pattern. The VLBI software team filed the anomaly as a possible station clock excursion, checked Masser Health, found nothing, and left the entry without edits. In New Mexico, the Apache Point Lunar Laser Ranging Operation saw return photons split into two clusters by tens of picoseconds during the window. Some photons returned early by amounts too small to move a mirror and too large to ignore. Atmospheric path corrections did not close the gap. Amateurs joined without knowing. Weak signal propagation reports from WSPR beacons sketched a global notch of diminished skip exactly as the moon descended through the favored long path sectors. Ham operators in the Midwest posted waterfall images with a narrow tide in the noise floor that only appeared when the disk neared the horizon, then attributed it to distant storms that were not there. Distributed software-defined radio networks archived their spectra, and the notch waited quietly in their raw files for someone to trace it back through time. The emails multiplied between Pasadena, Virginia, and Maryland. They carried the same short instructions, written in the passive voice and copied with care. The directives did not ask for conclusions. They asked for continuance. Accounting lines flowed as if nothing unusual required special funding. The calendars remained ordinary in shape. None of the numbers reached any public place. The moon, in the way documents showed it to outside eyes, continued as a cold, voiceless stone. Inside the files, the object behaved like something that listened and answered without sound. Along the Gulf of Mexico, a coastal surveillance camera guarding a stretch of Florida beach captured an annulus, a thin ring of light around the moon at the moment of maximum breathing. The device did not boast astronomical optics. Its frame rate was poor, and its image compression rough. It still registered a uniform, precise glow no thicker than a fraction of an arc minute, the kind of symmetry that atmospheric optics rarely sustain at sea level. The thresholding algorithm produced a pale band. A technician categorized it as a non-typical atmospheric corona and placed it where unusual weather went to wait. The file carried no tags that would bring it back. The quiet link hinted itself in timing chains and in clocks. At several radio observatories, the Allen deviation of station macers dipped marginally during the window, as if phase noise had been combed. Network time protocol logs from Stratum 1 servers registered fewer outliers. Packet delay variation compressed by amounts that would not trouble a user, but did not land at random. One engineer replaced a timing cable to be safe. The dip returned with the next gate and ignored the cable. On the oceans, small effects collected aboard platforms designed to ignore poetry. A Navy tide gauge anchored off Charleston drew a tide line that straightened like a taut string for a minute and then released. A buoy off Mobile Bay recorded microbarometer stillness. A fisheries research vessel in the Pacific noticed that sonar side lobes sank below their habitual levels. At the same time, a notch formed in ionospheric maps. No report connected them by intention. In after-action sheets, the words benign and transient appeared in equal measure. The return to S-band did not end with radar. Goldstone, holding to receive only for one window, logged a narrow, unmodulated carrier appearing on a polarization that did not match the site's last transmission and precessing with the period that had now become a calendar entry. The tone was not bright. It stood 2 orders of magnitude above background and kept itself aligned without flare or drift. Polarization analysis refused to call it reflection. The flip did not fit the path. When the window closed, the tone decayed, as if someone had lowered a fader gently, and not as a transmitter had been switched off. The staff annotated the graph with neutral timestamps and left out adjectives that could be read as narrative. At Green Bank, a cross-ambiguity function, built to catch transponders, produced a small peak when fed the Goldstone housekeeping code from internal test benches. The peak slid across the axis by the lunar Doppler rate and arrived 10 milliseconds early. The code was never transmitted on Sky. It lived in devices on racks. The team treated the coincidence as an artifact of the pipeline, recompiled their tools, and reran the window. The peak returned precisely where geometry demanded it. No one drew a line from the lab to the moon. The graph stayed local. The thermal questions advanced without help from adjectives. Data from diviner-style radiometers aboard the lunar orbiter revealed phase-locked excursions in several latitudes outside the poles. Local nighttime slopes warmed by a constant amount for a constant interval, and did so in wave fronts that flowed toward the sub-Earth point with the stride of a metronome. The flight team cross-checked with instrument housekeeping, with spacecraft attitude, with eclipse schedules, and with any switch that could make a false map. With each subtraction, the wave fronts held. The number 19 and the decimal 3 acquired the texture of a habit across disciplines. In Boston, seismologists running matched filters against long-decayed Apollo geophones extracted weak energy packets repeating at that rate, nested inside normal micrometeoroid thuds. In San Diego, oceanographers filtering microseisms under beach cameras found the same cadence eating a notch in their spectra as the ring appeared on a surveillance feed that had never heard of astrophysics. In Northern Virginia, a small office aligned 300 traces, normalized them to their own scales, and saw the sum rise into a shallow hill. Pilots reported nothing. Astronomers issued no circulars. The sky over cities carried its usual inventory of aircraft and satellites. The quiet persisted in instruments that normally disagreed about everything. It moved through systems with incompatible purposes like a hand passing underneath fabric, lifting each fold the same small distance. Engineers adjusted thresholds to keep alarms from firing. Analysts grouped the segments into folders with names that did not explain them. The file trees thickened. Edge cases multiplied at the margins. During one window, a meteor camera in Arizona caught 3 meteors crossing the lunar disk and found that their trails thinned by a constant factor while backlit, a change too small to mark as a calibration error and too regular to credit to chance. A Mascon modeler at Goddard ran a forward simulation and found that a slight transient redistribution of lunar mass could explain the gravimeter sway if the distribution shifted by distances no known process could carry in a minute. The paper that would have announced the simulation never moved beyond a draft. The draft lived in a personal directory and carried a file date that matched a moonrise. There were human traces as well. In a few labs, status lights glowed amber, where green would have been better, signaling workflows paused briefly by resource contention without failure. In data centers, the queues shortened unexpectedly as if processes had found faster paths that evening. In a coastal county, an automated emergency siren test, scheduled on a timer, fired 6 seconds late and could not be induced to repeat the delay. Time slices slid by the width of a breath and then slotted back into their slots without apology. The language of administration held its line. Memos moved with the firmness of decisions made elsewhere, requesting neither suppression nor proclamation, only the maintenance of procedure and the preservation of raw data in original formats. Procurement cycles advanced, service contracts renewed, and routine drills took place in rooms that would never mention the word breathing. If anyone tried to force a summary into existence, the attempt collapsed under the weight of specifics. The only summary that fit refused grammar. Near the end of November, the Florida annulus appeared again on 2 nights, each time when the window reached its widest. The ring's measured width held steady across both events. Pixel intensity distributions overlapped inside statistical noise. The camera's automatic gain control sat at the same number both nights. The frame contained a palm tree, a seawall, and a fraction of horizon. None of them changed. Only the moon wore a halo calibrated by a gate. In California, a relay at Goldstone failed in a way that lifted its noise figure by a small measurable amount. The repair logs show that the part was replaced the next day. The window that evening produced the narrow tone again, riding exactly at the threshold that the failing relay would have erased. After the repair, the tone stood cleaner and thinner. Its shape matched the curve expected of a system that was not radiating, merely restoring continuity along a path meant to be silent. By the time the breathing windows narrowed back toward their original span, the pattern had seeded itself into too many independent channels to be mistaken as a quirk of a single instrument. It neither shouted nor drew attention to itself. It held its metronome, leaned lightly into devices, and left when the minute ended. The moon continued to cast its familiar light. Beneath that light, in the clocks and in the baselines, and in the heat that backed out of models with reluctance, something had accepted a schedule they had not set and met them inside its narrow appointments without ever asking to be named. The final step had been designed to look like nothing more than housekeeping. In the night leading into December 19th, the transmit chain at DSS-14 switched from the broad, soft sweep that had become routine to a sparse sequence of low-duty, pseudo-random pulses shaped to resemble the framing habits of uncrewed spacecraft. The power stayed conservative. The effective isotropic radiated power kept below levels used in ordinary radar experiments, and the polarization held to the same linear basis that had produced the quiet carrier during prior windows. The pattern carried minimal information but maximal structure, a Barker-like preamble built from the primes 2, 3, 5, 7, expanded into unequal gaps, each gap longer than the last by a constant factor, and then an empty interval long enough to make the entire sequence look like a breath. The sequence repeated 5 times, each repetition bracketed by silence long enough to separate it from multipath. Goldstone's operators laid the pattern in with the same discipline they used for interplanetary commands. The exciter clock was traced to the station master, the up converter was temperature stabilized, and the amplifier bias was logged at 1-minute granularity. A secondary log captured antenna elevation and azimuth, sub-reflector position, feed temperature, and wind. A third log recorded phase noise and spur inventories, because a spur mistaken for intent would have been worse than no response at all. The beam went on target at the opening of the window and tracked the disk with the same smoothness used for deep space work. Green Bank took the role of listener on a frequency offset that kept it clear of any plausible leakage, its front end gated by the predicted round-trip delay. The buffer length exceeded expectation by a margin that admitted surprise but not confusion. Haystack prepared to chase phase on returns from the rough face and to track any specular that should not exist. A compact, privately owned dish in the desert Southwest stood by as an unannounced control, receiving only and writing raw voltages to disk. The first repetition came and went with nothing that anyone would have called an answer. The waterfall at Greenbank ran blue with ordinary sky, and the ambiguity function drew a field of grain that matched the moon's habit of returning its noise as if it enjoyed the roll. The second repetition looked the same in amplitude. Only in the phase plot, expanded beyond what any quick-look tool would show, a softness appeared in the trailing edge of the longest gap, a tilt too orderly to be random, and too small to survive a casual pipeline. The analyst stretched the axis farther than good practice encouraged, and saw a gentle asymmetry where symmetry had been planned. The third repetition carried the asymmetry forward and altered it. The pause labeled 7 in the scheduler's notebook tightened by fractions of a second. The nominal was the nominal only on paper. The real interval, measured against the station macer and corrected for Doppler, shortened in a way that matched nothing in the exciter logs. The segment did not collapse, it breathed in. On the fourth pass, a different gap, the one labeled 5, lost a sliver as if a resource somewhere had yielded to a prior claim. The loss did not resemble RF dropouts or front-end saturation. It resembled scheduling. The fifth pass restored every interval to its assigned length and left the phase flat to the limit of the measurement. Greenbank's processing array synchronized its marks with Haystack's archive. The alignment took time because the experimenters insisted on building their alignment from external clocks rather than from the data that interested them. Once aligned, the edge seen in the earlier campaign rose again. It came up in a place that geometry had no business recommending, on the night side, with only earthshine as a lamp. The specular cut itself into the return like a sheet catching a load and letting it go. It did not glide across the map. It appeared, reported its presence without fuss, and sat back down. Null tests bracketed the sequence. The same prime-shaped code was sent 5 degrees off the disk into empty sky at the same power and with the same timing. Receivers saw no phase breath. The pattern was sent again, with primes replaced by Fibonacci gaps, while the beam sat on the disk. Receivers saw the ordinary character of lunar scatter. The prime order was then kept, while the gap ratios were randomized. Receivers saw nothing that required a pen. The original prime order returned, the fixed ratios came back, and the phase softened again in the same gaps as before. Goldstone's team expanded their error budget. The exciter's jitter and the macer's short-term stability could not provide the asymmetric pull on the third pass without producing different traceable artifacts. A near-field coupling between transmit and receive did not fit because the receiving sites were not collocated. A reflection within the station waveguide would have generated multipath signatures at fixed delays rather than shifting pauses keyed to the code. The staff walked the racks anyway, measured all the connectors, tightened what could be tightened, and repeated the experiment inside the next window. The same small negotiation unfolded, an intake on the third, a clipped breath on the fourth, and straightness on the fifth. At Haystack, the Doppler color overlay rebuilt the same small geometry that had caused surprise during the first campaign. A shoal of returns synchronized their phase across patches too wide to be a local topographic accident. The shifts lasted seconds and resolved with a firmness that suggested a controller with a preference for scheduled order. When the data were masked to remove the areas most likely to harbor instrument bias, the shifts remained. When the mask was inverted to keep only the areas most likely to carry bias, the shifts did not move to follow the mask. The asymmetry followed the code. In Pasadena, a small group that had no public name tested the hypothesis that the phase changes could be an artifact of ionospheric structure. They drove a slab model with total electron content maps, seeded it with gradients more aggressive than physics would support, and synthesized delay series aimed to mimic the observed contractions. The synthetic delays refused to pick specific gaps without also distorting the others. The atmosphere could compress a breath, but could not choose which part of the breath to compress in step with an external pattern without coupling that no sensor had seen. A separate control sequence went up midway through the night. It repeated the same timing but inverted the order of the prime-labeled gaps. Greenbank recorded a corresponding inversion in the small asymmetries. Goldstone shut the transmitter and sat quiet for the remainder of the window. The phase plots at the receiving sites flattened. When the window closed, the staff archived the night in the same folder as routine, because there was nowhere else for it to go. During the hours that followed, the teams built statistics that would allow them to avoid belief. Monte Carlo runs pushed randomized codes through the same processing chain and counted the number of times chance assembled something that looked like intent. The count remained low enough to sit under the line used for internal claims and far below the line required for a public one. The language of the draft did not change. It listed only facts. Repeatable deviations correlated with a specific template, correlations absent under rotated or randomized templates, and no known natural mechanism with a record of producing this pattern under these controls. The last sentence held no claim larger than it could bear. Elsewhere, controls they had not intended as controls offered their own small reinforcement. The privately owned dish recorded the same phase breaths, lagged only by the length of its cable run. A deep space antenna in the southern hemisphere, scheduled for other duties but pointed near the limb for calibration, picked up the edge click in its side lobes and logged it as a maintenance anomaly. A timing server farm hundreds of miles from any of the instruments reported a minor and temporary tightening in network jitter during the 5-pass sequence. The report went to an operations queue and stayed there. The package that left Pasadena the following afternoon contained the protocol, the graphs, and nothing that could be mistaken for a claim. It moved through channels that had been used for decades to pass sensible requests between agencies that did not advertise their coordination. The sign-off came back in a day, bearing a signature that mattered only in rooms where names were less useful than roles. The guidance did not forbid work. It asked for appointments, for notice, and for company. It directed the teams into the corridor where many projects continued without ever learning to pronounce themselves. Publicly, the moon remained a place for poetry and for old data. The feeds that NASA placed on its front page talked about a meteor shower and a new look at Jupiter's atmosphere and a photograph of the Andromeda Galaxy that pulled at the habit of stargazers to share and to smile. The breathing windows did not enter any calendar that a reporter could cite. The prime gaps did not appear in any list of outreach events. The internal calendar, maintained in a spreadsheet that never traveled, named the period's stability phase and attached to it instructions that fit the temper of the teams. Do not press, do not provoke, and do not explain to anyone who had not already signed. In the weeks that followed, the threshold check was repeated in thinner versions, altered to blur its intentions. Sometimes only 2 primes were used. Sometimes the pause line was filled with low-level noise that carried the same rhythm under a carpet of 1/f. Sometimes the array listened without any transmission at all to comfort those who needed to see silence behave like silence. Each time the small choices returned. Each time the breath came in on the 3rd and snagged on the 4th and then made itself even. Each time the edge flicked on the night side for a second, as if a sheet settled under its own weight. In the logs, the word response never appeared. The word threshold did, attached to the method and not to the thing. The engineers continued to distrust the kind of noun that could not be measured. The measures were enough. They had stepped to the lip of a conversation and held their voice at a volume they believed would not echo. What came back did not resemble language. It resembled acknowledgement the way a nod resembles a greeting. It did not invite, it did not warn, and it did not repeat outside its minute. It kept the time they had set and then let the minute end. Snow had settled on the empty concrete at Goldstone, a thin, chalky veil that softened the hard geometry of pedestals and cable runs. The great dishes held their positions through the holiday lull, elevation drives locked, azimuth brakes engaged, sub-reflectors parked. Ambient telemetry flattened in the cold. The station sounded like a building that breathed once an hour. In Pasadena, the habit of making a long shelf out of a short night took over the rooms where the graphs lived. Technicians and analysts folded months of material into a single object, meant to last. A long-term retention package with checksums stamped on every layer and redundant custody notes that treated the contents as if the only failure worth fearing would arrive in the form of forgetfulness. The package contained the familiar pieces that by then had become a vocabulary. The windows with their 19.3-second cadence sat in one directory, stacked by date and lunar phase, each entry bundled with the stationmaster records and the weather logs. The polar thermal plateaus, trimmed to the regions that had refused to cool on schedule, sat in another, with radiometric calibrations and angle of incidence tables appended so no one would be tempted later to explain warmth with the tilt of light. A third directory held the Doppler edges, those sheet-like returns that should have had no specular parent and yet had chosen to appear and vanish like metal, deciding whether to carry a load. A fourth held the gravimetric nanogals, line weight wavering by single-digit parts in a billion, annotated with the superconducting gravimeter's coil temperatures and local barometer, so that air would not be asked to impersonate structure. A fifth held the timing deviations in the pulse gaps, the millisecond grade compressions and omissions that had declined to scatter themselves randomly and had instead followed the human schedule as if it mattered to them. The front of the package carried a label that would pass any audit by looking smaller than the thing it named, a Latin word that suggested gaps rather than claims. It sat under a cover sheet that listed custodianship, retention period, distribution class, and a routing path to cold storage that would place mirrored tapes on different coasts. The internal index pointed to a bridge table that tied together the windows, the plateaus, the edges, the nanogals, and the gaps by universal time and by a phase marker defined against the lunar ephemeris. The bridge existed to keep the pieces from drifting apart, for anyone who tried later to argue that they had never touched. A month later, the first Freedom of Information requests arrived and took their places in a separate archive. The responses went out with the careful voice that institutions use when the only safe action is to refuse to teach. They described scheduled calibrations, routine outages, seasonal weather patterns over the Mojave, and the ordinary optics of winter skies. They pointed to public pages where the moon remained basalt and regolith and impact history. They repeated a stock clause that formalized a cultural reflex. The matter did not qualify for elevation beyond operations and analysis. The clause had served other cases, and it served this one without effort. In storage rooms adjacent to racks of spares, paper lived the way paper always had. Wide rolls of plots lay in their craft sleeves with pale blue lines receding from an axis of 0. Each roll tagged with station, date, and a catalog number that meant nothing outside the room. On the cover sheet of one set, in the modest pencil of an engineer who had been trained to record and not to perform, a margin line summarized a private inference. If the thing behaving like structure existed, it behaved as if dormant. The line carried a station indicator and a timestamp that led back to the night when a portion of the lunar disk had acted like a mirror and then stopped. In Flagstaff, a field scientist kept a print of a polar crater inside a drawer that also held hex keys and lens cloths. The image showed the rim and the floor and the plateau that had rested 2 to 3 kelvins above expectation for hours that did not fit any solar model. The edges of the plateau had the unornamented look of hardware, not the plucked texture that rocks usually show when numbers take them apart. In Green Bank, an operator who had factored surprise out of his working day had stopped trying to flinch at the short, clock-like clearings that slid across the noise temperature curve when the lunar disk came to the correct altitude. In Laurel, an analyst who had stepped away from constellation dynamics to hold a quiet part in this story, returned to the span markers on the windows and noticed that the 19.3 seconds did not always hold to the third decimal place. At intervals, they shortened to 19.2 in a way that suited the idea of load shedding better than the idea of random drift. The microtremors lodged in the habits of people who did not endorse legends. They entered as numbers and remained as numbers. Elsewhere, Other fragments refused to vanish. The coastal camera that had drawn a clean ring of light around the lunar limb during one of the wider windows persisted in the archive and continued to bother the person who maintained the file list, because the entry lived among weather and waves and kept looking architectural. The southern dish that had caught the edge click in a side lobe during a calibration routine had filed the anomaly under maintenance and had kept it there, where it sat like a boring note that would not die. A timing server farm whose logs had briefly tightened during the 5-pass sequence had filed the episode as an infrastructure event and treated it as a lesson in how quiet could be measured as well as heard. The public story did not make room for any of this, and the teams did not try to press against that boundary. The moon rose and set with its tides of attention, and classrooms told the story of its seas and highlands with maps that borrowed their palette from mid-century atlases. University lectures presented voids and basalts and regolith depths measured by radar, and a mention would sometimes be made of cavities in the crust that could ring. Where the silence of instruments met the soldiery of well-kept notes, vocabulary remained sober. The word that traveled between pages was unknown, and it was written without apology. Inside the sealed report, the 6 sections that had been assembled under the eyes of people who had learned to leave their names out reached their end without switching from description to declaration. The last section moved through risk as through weather. It listed the ways in which outliers wear out their observers, and the ways in which the desire to turn an outlier into a narrative harms the instrument more than the outlier does. It set down a practice dressed to look like modesty but functioning as discipline, to wait with geology rather than to sprint with rumor, to treat a cyclic phase change like a phenomenon and not like a phrase, and to refuse to accelerate a system that had chosen to set its own tempo. The distribution list for the report was short and narrow. Signatures on the routing page sat in the same soft ink that had moved across this quiet corridor for decades. One of the custodians marked a review date 6 months out, aligned with a season when the geometry between Earth and Moon would shift by just enough to make any repetition decisive for those who needed another repetition and invisible to those who did not. An action item specified routine instrument maintenance to keep the next night honest. Swap the feed coolant at Goldstone, calibrate the noise diodes at Greenbank, refresh the temperature map flats for the polar mosaics, cross-check the superconducting gravimeter's tilt sensors against a redundant pair, and rotate the raw voltage storage at the private dish to prevent silent bit rot. Departments tasked with guarding budgets filtered the work through their ledgers and decided it was cheap enough to ignore. Departments tasked with guarding reputations decided the subject could not be made to speak loudly enough to threaten anyone who ached for headlines. The small office tasked with guarding coherence across agencies requested only that future sessions be scheduled with notice, and that the codes used for probing remain as short and as sedate as practical, until someone with accountability for larger systems felt like choosing a stronger pronoun than it. At the edge of the teams, there persisted a private metaphor that had been kept out of text. In conversation reduced to nouns and verbs and glances, it took on and put down the shape of a hull. The metaphor did not make it into the figure captions or the summaries or the distribution emails. The report stayed with the language of mappers and meters. In that language, the lunar system had behaved at times like a medium with an internal order, and at other times like a reflector with a preference for certain codes. It had accepted energy without heat where heat should have been, and it had returned phase shifts where roughness should have smeared them. It had tightened and released in a schedule that belonged to rooms in California and Virginia and Massachusetts, and had then resumed its stone manners as if the minute mattered only once. Outside of filing rooms, winter passed, and the Mojave learned again that ice evaporates like a whisper. Technicians ran the thaw checklists, bled water out of conduit boxes, cycled relays until contacts were clean, and rolled the azimuth gears to move old grease into new bearings. The seasonal pulse took back the place physics had lent to anomaly. The fact that the retention package existed did not change the fact that most work would be ordinary and would stay that way. The last page of the report carried a table of open problems that could be mistaken for any other table of open problems if the reader wore a generalist's eyes. The items asked for more careful measurement of phase under low illumination, for better modeling of ionospheric structure during the windows, for an expanded catalog of thermal behaviors at polar depths, for a slower, longer look at gravimetric noise across holidays, and for a protocol to manage human expectations when instruments delivered precise uncertainties instead of appeasing stories. There were no milestones that fit a press release. The dates were placed where careful teams place their dates, in the dull months where stubborn work survives. The question that had arrived in the minds of people who stand outdoors at night did not leave with the filing of the package. Within the teams, the thought persisted like a tide below weather, not in the shape of a sentence, but in the shape of a posture. The internal answer did not grow fancier than the data that had earned it. The instruments had measured a set of responses that behaved as if a structure had chosen to acknowledge a pattern and then to rest. The silence that followed, measured in phase instead of sound, belonged to the object that had chosen it. The rest, assigned to the side of the work that does not write, remained where the report could not go.